Okay, so these are hard organic molecules to name and hard organic molecules to draw. So I've got 6 molecules to name and 6 to draw. What I want you to do again, please just pause this video, see if you can write the names to these, and then see if you can draw the names of the ones where draw the molecules where you've been given the names. Just after that, start it up again, and I'll go through the answers. Okay, so this first molecule here has 4 carbons in its longest chain. There are 3 substituents coming off: a fluorine group, a methyl group, and a hydroxy group. The hydroxy group, the alcohol group here, it will change the suffix on the end of the name to -ol, and it's off the first carbon because it has the highest priority. So this is butan-1-ol. So we're going to name this 4-fluoro, 2-methyl butan-1-ol. So the next molecule we have here is we have 1, 2, 3, 4, 5, 6 carbons, the longest chain. That's going to be a hex. We have an amine, a methyl, and a chlorofunctional group. So a chloro, a methyl, and the amine is going to change the suffix. And so that also, we're going to give the amine the priority to the numbering. So we're going to go 1, 2, 3 and give it a number 3. So this is going to be hexan 3-amine, and it's going to be 5-chloro 4-methyl hexan 3-amine. So the next molecule, we have 1, 2, 3, 4 carbons in the longest chain. We have a carboxylic acid group attached, highest priority group, a bromine atom, and a methyl group attached. So we're going to start numbering from the carboxylic acid end, and the suffix is going to be enoic acid. It's going to be butanoic acid, and we're going to end up with 4-bromo and 3-methyl butanoic acid. So the fourth molecule here, again, there is 1, 2, 3, 4 carbons in a row. We have a carboxylic acid on the end, so it's going to be enoic acid. It's going to be butanoic acid. We have a chlorine and a fluorine coming off the 2nd and a fluorine coming off the 4th. And remember, we're going to write the chlorine first before the fluoro, sorry, the chloro before the fluoro, because we write our prefixes in alphabetical order. So this is 2-chloro, 4-fluoro butanoic acid. Okay, so the next molecule here, 1, 2, 3, 4. Again, notice the carboxylic acid is on the left-hand side, not the right-hand side. It is still in the main chain of 4, so this is going to be butanoic acid again. We have an OH group. We can't, because we've already used the suffix for the higher priority carboxylic acid. The OH group is now going to be a hydroxy group and a methyl group. And because we number from the carboxylic acid side, the hydroxy is coming off 2 and the methyl off 3. So this is going to be here 2 hydroxy 3-methyl butanoic acid. So the next one we have here is there are just 2 carbons in the chain. This is an carboxylic acid, so it's ethanoic acid, and there is a chlorine atom or a chlorofunctional group coming off the 2nd carbon. Remember, we start numbering from the carboxylic acid side, 1, 2. So this is going to be, we could call it 2-chloroethanoic acid, but we only need to call it just chloroethanoic acid because 2 is the only part of the molecule it can attach to, because the carbon that is part of the carboxylic acid functional group has used up all 4 of its bonds. Therefore, this is called chloroethanoic acid. Okay, so the next thing we need to do is draw this molecule. So we've got 3-aminobutanoic acid. Butanoic acid, remember, but 4 carbons. We're going to draw 4 carbons in a row with a carboxylic acid functional group on the end, double bond O, and joined also a single bond to an OH group. And then as we number along the carbons, that amine group is going to come off the 3rd one, and it's going to look like this. The next one, 3-hydroxy 2-methyl propanoic acid. Okay, so we've got 3 carbons with a carboxylic acid. Off the 3rd carbon that's furthest away from the carboxylic acid group, we're going to have a hydroxy, which is an OH alcohol group, and off the 2nd we're going to have a methyl group, and it looks like this. The next one, bromobutene 2-ol. Okay, this is actually I've written down here trans 3 bromobutane 2-ol. You can't get a trans bromobutane 2-ol, so let's just assume that this is a butene 2-ol, and we'll draw it like this. These two functional groups are trans from each other, or you could also say the two CH3 groups are across from each other. 3,4-diaminopentanoic acid. Okay, so 5 carbons in a row because it's pentanoic. It's going to have a carboxylic acid functional group on the end, and 2 amines coming off the 1, 2, 3, and 4th carbon. Next molecule here, 2-amino-bromobutanoic acid, 4 carbons in a row with the oic acid. Bromo coming off the second one. Remember, we number from the carboxylic, start with 1 on the carboxylic acid function group, 1, 2, and 3 for the amine. Last one, methylbutanoic acid, 4-fluoro, 3-hydroxy alcohol group, 2-methylbutanoic acid. So 4 carbons in a row with a carboxylic acid, and then a CH3 group off the second, OH off the third, and a fluorine off the fourth. And there we have it. We have the naming for these more complex or harder molecules. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.